Fabulous. Let us know, Hank, when we're live. Hi everyone, welcome back to Global AI Community on Virtual Tour. We had a little bit of a delay, but we're going to get straight back on with things because we're agile like that because we're all into technology. Firstly, I would like to welcome Patricio, who is going to talk to us a bit about reinforcement learning using Azure Cognitive Services. And we haven't heard a lot about this today, so this is very exciting. Patricio, just one question for you before we get started. Whereabouts are you based and what time is it there?
Yes, I'm in Santiago, Chile, in South America, and here is 4 p.m.
It's 4 p.m. Fabulous. We are hitting just gone 9 p.m. here in the UK and a little later around Europe. So welcome to the global stream. And yeah, please take it away and share your screen.
Excellent. Thanks, Amy. Thanks, Sammy. There it is. Can you see me okay?
We can.
Yes, we can.
Excellent. Okay, so thank you so much. Thanks to all organizer team for what you are doing and for the flexibility in this small technical issue. However, I'm so happy and glad to be with you and share subset that use one specific method, which is the multi-layer neural network. So in terms of machine learning, we have three main kinds. So the first one is supervised learning, which is most of the machine learning cases we know so far. Most of the examples we have seen so far are basically supervised learning, which is the case where the system learns based on structured or unstructured data, but previously classified. So in the examples at the right, you can see a couple of dog faces, and then you have the relationship with a label, which tell us that this is a dog. In the bottom images, we have the same for cats, and we have a relationship, we have a label and a tag for them that say this is a cat. Okay, so data in here is data and labels. The goal is to learn a function that maps x to y's. And some of examples of supervised learning are classification, regression, object detection, etc. The second kind of learning is what is called the supervised learning, and in the last years is also called the self-learning, where the model is built using data as input, which has not previously been classified. So in here, we do not have labels. We just have data. We just have a lot of features. We have several data points, but our goal will be to learn something underlying, hidden into the data structure. Okay, so in data, we have just data, we have no labels. As a goal, we want to learn something new, something hidden, underlying behind the data. And examples of this are clustering, segmentation, feature learning, and some other examples. In the image, you see a very classical image, which is the NIST number identification, where we only have numbers. We do not have the tag for this example to say, okay, those numbers are number 5, those are number 9. We just have the data points, we just have the pixels, and from the pixels, you can find that segmentation do a good job by putting numbers pretty much all together. So all the 5s are in the same place, all the 9s are in a separate place. So then we can pick some examples of them and find out, okay, so all this cloud are the number 5. All this cloud is the number 9, even though we do not give the tag for the method to learn. The third learning technique into machine learning is the reinforcement learning, which is inspired on behavioral psychology, where we want to determine what action an agent should do in order to maximize an intuition of something called reward, okay, which is something that we give back to the system to learn, and we have the complete flexibility to write our own reward functions. Okay, so the method do not require our internal how we are rewarding. They just need the number, they just need the score, they just need this reward that we are creating, and we're gonna see demos on how it works. In the image, in the GIF shown in the screen, you see Mujoko, which is a classical example of the gym AI, where this humanoid image is trying to learn to stand. So what movements should I do to stand with no any previous knowledge on how a human used to wake up, used to get up, stand. So he's just trying, exploring movements, and eventually he get a stand, and he get the higher reward. So for example, we'll give 100 points if he gets to stand, and so he get the reward. So in terms of data, there's no historical data required. Everything can be explored, everything can be simulated from the scratch. The goal is to learn to take actions that maximize a reward, and examples of this are the automatic control, locomotion, all of the Atari games you probably have seen on on videos, and all and obviously Alpha Zero, which is the algorithm that DeepMind created to defeat the current human champion of the Go game. So as a summary of the types of learning, you can see that in the case of supervised learning, we have data and we also have labels. In the case of unsupervised learning, we have data, but we have no labels. So this is the challenge, and these are other use cases where eventually you can, when you do not have labels, you have the opportunity to eventually find a new label, to find any tag that was not even expected. So in these cases, unsupervised learning is a much better choice. For example, if you are trying to find fraud, or you are trying to find bad uses or something, or spam, unsupervised learning is a good choice, because it can also find new patterns on how tricks are done over a system in order to make a fraud. And finally, we have this reinforcement learning that I'm going to talk today, where we have no data, and also we have no labels. Can you hear me fine, right? Yes.
I can hear you well.
Okay, thank you. Okay, so let's go a little deeper into reinforcement learning. Reinforcement learning is a set of techniques that allows AI to experiment and learn. In here we have an AI model that initially is pretty simple. Is all exploration. It has no previous knowledge, and it starts to try something, to try a movement, to try a movement of the joints, for example, in the Mujoko example that in the GIF that I show you. So from this example, we go to the world, and I put the world with a mark, because a world can be the real world if we are putting an action into a machine or a device that do something, but also can be a simulation. And this is pretty interesting when we go, for example, in the Atari games, we are going through simulations. So through simulations, we can do many experiments, like thousands of experiments, millions of experiments, equivalent to 100 years of human experience, and we start learning. We start getting rewards from the score of the game, and then we go back to the model with what we have learned, which is in this case the reward. Okay, so this is basically how reinforcement learning works. In reinforcement learning, we have two 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 ways to use it. So the first one is to exploit, which is a strategy in which we use the best known inference that we do have. So as much as the algorithm have learned, it start exploiting this knowledge and giving actions based on his best knowledge. Okay, so but one interesting thing of reinforcement learning is that it can also explore. So it can also try movements outside of their knowledge space. So for example, if he has never tried to move the elbow in order to try to stand, he will do an experiment. He will just explore. He will try to do a new movement, not based on his best knowledge, but in his exploring ideas, in order to try to find a new, better space that maximize our reward. And this is basically how the reinforcement learning works, by exploiting in one hand and to explore in the other hand. Okay. So here you probably might have the question on how much should I explore and how much should I exploit. Okay, so I'm going to show you in a couple of slides how Azure give us this flexibility, and how we can balance these two strategies. How much should I exploit, probably getting the the best our best knowledge, and how much should I explore in order to find new spaces that maximize our reward. Here is an example where, for example, a coffee shop through a chatbot. So initially, we get an intention from a user. So the intention eventually asks for a coffee or a tea. Okay. So in our app, we can find out that we have three options. It's a pretty easy example. We have the espresso, the mocha, and the latte. So we go to the personalization service, and we give the options we have. So the personalization service will find out a way to rank our options based on his best knowledge or an exploration strategy, and eventually the mocha gets the highest score. So we're gonna present the option of mocha to our user, and the user will eventually asynchronously, and this is interesting, the two actions do not need to happen synchronously. So in one hand, we present a ranking, or we present a single option, in this example, the mocha, and asynchronously, eventually a couple of minutes later or a couple of seconds later, we'll get a reward. And the reward will be 1 if the user accepts our choice. The reward will be 0 if we found out that the user do not like our recommendation. So these are the two messages that we pass to the personalization. First, we pass the options we have for a context, for a specific context of the user. For example, what device is he using, if he is logged or unlogged, etc., etc. We can give to the service as much info as we can collect from the user and from the options that I want to give him. And then a couple of seconds or minutes later, we can give to the personalization service the reward that we have captured from the reality. Okay. Other nice examples that Microsoft is actually using in the services are in the Skype calls. There's a lot of settings, and one of the settings is called the jitter setting, which is actually there's not one rule for all. There's not a one simple heuristic to calibrate the jitter. So what Microsoft is doing is collecting a lot of feedback, is having some experimentation or some best knowledge setting for a specific user. And when I mean a specific user, I mean which browser is using, which client is using, which I don't know how many hours has been logged, and the battery level, the Wi-Fi strength connection. So the jitter eventually can take different values by facing these different scenarios. So at the end of every call, you probably have seen that Skype and all these video conference solutions ask you for a feedback, and through this feedback, eventually there is, and the model can learn again. We can find new jitter settings. We give it to the customer, and eventually we will start finding new rewards. Okay, so this is a other way how reinforcement learning is being used in a real service in Skype. Okay, so other things that can be done to reinforcement learning. So is, for example, content items, this or that. If eventually in a website we have some options, well, we can use reinforcement learning to learn the best strategy for every user context. If he's in a tablet, he's in a mobile, he's in a cloudy day, in a rainy day, as much information as we can collect, we pass it through the personalization, and he will return for us the best strategy for this context, which has been learned through the cases. any content action. For example, if we want to show an action for a customer in order to follow a desired pipeline, and the suggestion can be continue watching, continue reading, give them a social activity option. We can buy a pass or buy something, so we can somehow change the customer journey by showing different activities. Also, there's the content layout. We can do some experiments on which is the best layout for a specific activity. This is what in the past was called the A/B testing, and I'm going to show you how different is this from A/B testing, and so on. So there you can imagine whenever there's a decision on what to present, what options to present, what should I suggest to our customers, given a context. Probably this reinforcement learning and the personalization service can be a good option. So let's go through the personalization. In personalization, so for example, Paula is watching an original series on weekend from home. So you can see that the scene is quite relaxed, is using a tablet, so probably she's not that busy or anything. But it's much different from the experience of someone commuting using his mobile phone, and probably through a different experience in his mobile. So the question is, should they do see the same content? So probably we can think that no, we can show different contents. But here we can take two strategies. So the first one should be to use knowledge experience from humans to say, okay, so probably in the commuting I'm going to show smaller contents, smaller news in more compact format, and something that can be seen quite well on the mobile phone. And in the other side, for Paula to show eventually longer text, longer videos, and more heavy items that require more Wi-Fi strength. So this is one choice to use our best knowledge. But also, what if we try to use this black box strategy on do not use any pre-existing idea, do not try to put our existing knowledge on what's best in one situation or other. We just start learning. We just put this engine to learn, put this engine to capture what's best in different scenario, but with no previous knowledge, no previous ideas. Okay, and also there's some stuff in the literature, and these are some statistics from McKinsey and Microsoft Services that show that the customer experience pays off. So we can get a higher customer satisfaction. So there's some 20% extra on customer satisfaction before and after using personalization. We can find some 10 to 15% measured increased revenue growth by before and after using personalization in general. And also it has been documented that you can find some cost efficiencies, so from 15 to 20% before and after start using personalization. However, personalization are still a work in progress. There's a study from Gartner that shows that 81% of the executives think that they will soon start competing only on customer experience. This means that as experiences are starting to become more digital, in a technology is more or less the same for all competitors, all the difference will be in the experience. Okay, so there's a agreement. 4 out of 5 executives find that that they will be competing on experience. However, only 20% of them or 22% of them think that they are exceeding their customer expectations in terms of experience. So there's still a lot of work on here, and this is where the personalization service and the personalization strategy fits. Some difficulties of the typical approaches. First of all, personalization requires a lot of exploring on the intersections of a lot of dynamic factors. Okay, so not if in a traditional setting, in a traditional data science settings. So eventually we will collect some data, we will try to learn something, we will put this into production, and it will eventually will make inference over the known space that we have. Okay, but the reality is a little bit more challenging. We have changing interests, so user can change preferences. For example, through novelty, through popularity, even though some virals that are present for 2 to 3 days that are popular and people tend to prefer. However, this as this is a viral content, eventually it will appear and eventually will disappear. Okay, so there's a lot of things in there. There are complex behaviors like you are commuting, you have a low battery level. Should I change the content because your battery is too low? We can create a hypothesis, but it's much better if we try to learn something through experimentation. Okay, so these are typical pitfalls of the traditional approaches. So in A/B testing, what we used to do is first we need to design the experiment. Okay, so the experiment have a creator, which is the user, the analyst, or whoever is guiding the process. We do the test online once, we get data, and we eventually start over trying. For example, if we found any banner that works better in terms of conversion, we take this option and we eventually create a new experiment to do a new exploration. When we use reinforcement learning, the exploration policy will tell us if we should exploit our best knowledge. And when I mean exploit our best knowledge is to do thousands of differences in what I can show to the customer, depending on the user input that I do have or the user context that I am able to collect. Yeah, like for example, the battery level, the how cloudy is the day, and so on. Or the reinforcement learning and the personalization service will determine if it's a good moment to explore new alternatives. Is to try something initially random, but with the time, the optimizer will start selecting for us new strategies that that is not into our best knowledge, but is worth to try and to see if we get a better reward. Okay, so in here we use the best model to exploit and explore. We record the user interaction through reward that is being captured, and we found the best policy that fits the reality and fits the whole complexity and the whole variety of users we can have. So here is basically what we are achieving. We are doing a one-by-one experiment in A/B testing, but in the reinforcement learning and by using the personalization service, we can do 100,000 different choices that will be presenting and collecting feedback and reward. Okay, so let's see a little on Azure Personalizer, which is the service that Microsoft provide us to do that. So first, the first feature of it is that we can do contextual engagement across the customer journey. So the whole journey will be guided through this black box, eventually learning from everyone, from every context, and giving different suggestions and journey paths depending on the context. Second is a real-time personalization at scale by the use of two APIs, and I'm going to show in the example how easy is this. So first we have the API to present the alternatives and the context of the user and get a ranking, and the second API is the one to collect the reward. We can, with this, leverage data about user, about the whole context of the user, and I'm also gonna show it in the demo. And we have full flexibility to write our own reward function, which is probably in the business are the KPIs. So we have the full complete flexibility to write it as we want. We do not need to declare the reward function that we are using to the optimizer. We just code it and we just communicate with the service by giving them the reward value, not the reward function. Okay. So more or less, the personalizer works in this way. The users bring some context, like the device that I'm using. We have some choices for them. In these choices also have features. For example, one choice can have more text than other. One content, one action can be more into the red colors and so on. So the context and the action are given to the inference model. The model will choose if he want to exploit or he want to explore. He will rank the actions to the user, and the user will do a selection. We will code a reward function, and we will give it back to the service. The service will join what they suggest, the reward they got. He will write a log and eventually will train again the inference model, learning from the new experiment he did. Okay, the whole experience can be done completely cloud, or we can also use containers, so we can have a lower latency if this is a website that have a many requests per minute. So here are the Azure Personalizer, the screens into Azure. So as you can see, first you have the rewards, and you have a parameter called the reward wait time. So here we can set how long we can expect, how long we need to wait in order to get a reward. So we can eventually do a timeout. If in the example we're giving 15 seconds to collect the reward. So the service is providing a ranking, is providing us some options, and he will wait for 15 seconds, or we can determine, we can wait for 1 minute or 1 hour to get the reward back, and eventually get some reward aggregation if we get more than one reward in the whole span time. Also, if you can see, there's a second parameter, pretty interesting, where we can find how much we want to explore and how much we want to exploit. So we have these two strategies, and we have the full flexibility to determine how much we want to explore, how much we want to exploit. And at the end, you also have one parameter in order to calibrate the model update frequency. So if we are collecting data every 15 seconds, we can also determine that we want to retrain our models every 15 seconds. Okay, and this is just a parameter that the Azure Personalizer takes. Other cool setting, other cool feature of the Azure Personalizer service is that we can start measuring all the curves that happens. So what's the average or the total reward we are getting by using different strategies that are being measured in the internals. So even though we are exploring and exploiting, in the background, it's also measuring some stuff, like, for example, how a random strategy would have worked. So here you see that a random strategy eventually collects some reward. But by using the best learn policy, we get this this upper line. So the whole difference between the average reward in one case and the average reward in our best scenario can be eventually monetized. If this is a funnel of an e-commerce, for example, this is our more sales. Okay, so we can eventually monetize this difference. Hello?
Hi, Patricio. Sorry, just a quick one. We've probably only got about 5 minutes left. So
Okay.
If there's anything particular you want to show, it'd be great to see it now.
Okay, I'm gonna rush.
Okay.
And then in the last thing I want to show you of the internals of the Azure service is that it also gives us some feature explainability by showing us the features that are adding more to the learning, in which eventually some features that are not giving us a lot of knowledge, so are just adding noise. So we can decide not to collect this background information, just go ahead with and get rid of it and eventually try to capture other ones. So this is a cool feature, and is somehow how Microsoft is trying to take the whole feature explainability in the whole AI stack. Okay, so let's go to the demos. I'm gonna change screen to my Visual Studio. Where is it? There it is. Okay, so can you still see my screen, right?
Yeah, we
Yeah,
can
I
see
do.
it.
Excellent. So first, we're gonna go to the business demo, which is one of the demos Microsoft have for it, which simulates a regular content site with news, with some images, with some content that eventually would be nice to see how it changed from one user to the other. Okay, so fortunately we have the whole code in here. We have how the personalizer is being configured. We need to give them obviously the endpoints that we set up in the Azure Spring. We also can give it the keys that I manage through here to the user secrets. Okay, so with this, by just giving this small configuration, I can just run it. Okay, and as it deploys, it will show us a case, a simulated case. In this case, we have some content that I want to show to a user. So I just get into my first screen, and let's see, for example, I want to see a personalized article. Okay, so I click in here, and I got an article that fits for me based on the knowledge the algorithm have, or what he's exploring. If I hit F5, eventually it will start exploring and providing me other options in there. So for example, there it eventually decided to explore if this other content is also good for me. So most of the time gave me the best option for me, but also in this case, he eventually tried to explore. So let's see how it works. And this is a cool part of the demo. Here you see what are the referrer. For example, if I go to the site through a social, I go to the site through an email. So let's see what if I came from an email and the current tournament is Wimbledon and my device is a tablet. So I will see, okay, so my personalized article suggestion is other. It's not the same. So let's see now in social, Mutua, and mobile. And I got the same, or eventually I got other. So in the internals, how it is working, first we are giving to the service our best context we can collect. So in this example, the context is that my referer is social. I go to the site through a social website. The tournament ongoing is Mutua Madrid, and my device is mobile. But here we can also extend and we can expand the data collection. And if I click the user agent, also can find what's his device. In this case, I'm running a Windows 10 in my desktop through a Mozilla browser. So it's interesting to give also as much information as I can collect. And in the other hand, the possible action in here, you see that are three different content options. So one is something about women tennis association. The other one are some other news and with a couple of, I would say, metadata about the content. But here are other cool stuff from Microsoft that we can also use the cognitive services like the text cognitive service or the image cognitive service in order to extract a little bit more from the image. So for example, if I click in the text analytic, this first image not only will have this metadata that means that this is Wimbledon, is from London, but also let's see in here you can find that there are a lot of intentions and phrases captured from the just by using the cognitive service. So we can give to the personalizer service more context on the user, more context on the options, and eventually he will learn. In this example, it also runs a sentiment analysis, so we can found that in some settings a neutral sentiment is better. In this other option, is a higher sentiment, is a more positive sentiment. So eventually the thing will learn and give us and learn something about how one sentiment fits better for one context. Also, the demo is showing us that here is exploiting, or eventually he will be using the learned model. So it's also an option. The last thing I need to show is if I get to click the article, it's kind of a success. And we can code the reward function as we can. For example, in this case, the reward will be how far in the article I go. So if I scroll it to the top, to the end, I get the maximum reward. So I can go back, and the reward was collected that I read the whole suggestion that I got. So we have the full flexibility to write our reward as we want, and we provide the score back to the service. In pretty
Yes. Yeah, 1 minute.
Thank you. And I'm gonna go pretty quick to other demo. Let's stop this one, and we'll go to a second one, which is a different scenario. It's a travel agency that is also trying to optimize his conversion funnel. And I'm not gonna show you the details, but I'm gonna just deploy. And in this case, what I want to show you, because the setting is relatively similar, we are deciding what is the best content I need to show in order to maximize the funnel conversion, is that the reward function is created completely in a completely different way. So here we have a completely different reward function. So in here, let's see, we have a shopping cart almost done. We will go to the checkout, and the decision I want to make is this the best banner that maximize conversion? So here you see that the conversion is reward is already running, is in 0.8, 0.7, so it's getting worse depending on how long I take to click buy. So for example, if I click it right now, the reward of 0.5 was collected. Okay, so or for example, if I go again and I get a, let's see, let's go again. Eventually, I'm gonna get a different banner. Okay, so here I got a different banner, but what if I decide no, that banner is not that good, or it creates a feeling in me, so I'm gonna just save it for later. And my reward function said that if I save for later, I collect a 0.2 reward. Okay, so this is how flexible it is. This is all the flexibility we have to write and to code our own reward function. So I think I'm done. Thank you so much for joining. It was a complete pleasure for me. Thank you again to the organizer. You're doing an awesome job collecting all this, pulling all this together, and count with me for any other thing. And please, all questions I'm gonna now plug to the chat to answer as much as I can.
Perfect. Yes. Thank you so much, Patricio. I'm so sorry we had to rush a little bit at the end. Your demos are fantastic. Yeah, if people have